Okay, so this example I've chosen because it has multiple critical points and lots of stuff to it. In the end, we're going to graph it and look at the graph and see how the answer matches up with what we got. So we're asked to find the extreme values of the function and where they occur. So the first thing we need to do is dive in and take the derivative. So when I dive in, I'm going to say y, before I take the derivative though, I'm going to just raise this to an exponent. So the 3 plus 2x minus x squared all to the 1/2. Okay, now I'm ready to take the derivative. So when I take the derivative, that's going to give me 1/2 times 3 plus 2x minus x squared all to the negative 1/2 times, now the derivative of this is going to give me 2 minus 2x. Okay, and excuse me. So when I go to clean this up a little bit, I'm going to get y equals, and the numerator is going to be 2 minus 2x, and then the denominator I'm going to end up with 2 times 3 plus 2x minus x squared all to the positive 1/2. Okay, now I can factor a 2 out of here and here, and I can factor a 2 out of there. So when I do that, I'm going to be left with y prime is going to equal 1 minus x over, that 2 will go away. Then I've got 3 plus 2x minus x squared all to the 1/2. All right, so now I have the derivative, and now I've got to focus on my critical points, okay? We know that critical points are in one of two places. We know that critical points can be where a function, the first derivative, is undefined, okay? Or it can be where the first derivative is equal to 0. Okay, so let's look first where it's undefined. Okay, it's going to be undefined whenever the denominator right here equals 0. The function would be undefined. So if I do that, I'm going to say 3 plus 2x minus x squared. And if I do that, that has to equal 0 because you don't want the denominator to equal 0. So if I bring everything over to the right side, then I'm going to be left with 0 equals x squared minus 2x minus 3. And that can be easily factored because I can take factors of 3 and factors of 1 and they add to negative 2. So this should be a negative and a positive. So now if I use the zero product property, I'm going to say that x minus 3 has to equal 0, or x plus 1 has to equal 0. So x then is going to equal 3, and x here is going to equal negative 1. Okay, so in the next case, I want to look at where the first derivative is equal to 0. Okay, so I'm going to take this function right here and say 0 is going to equal 1 minus x over 3 plus 2x minus x squared all to the 1/2. Okay, and what happens nicely with this problem is when I cross multiply, this just goes away. So I'm left with 0 equals 1 minus x. If I add x over to here, I get x equals 1. Okay, so now I have just developed 3 critical points. Okay, my 3 critical points are at 3, at negative 1, and at 1. And let's get rid of that because that just disappears. You can't see it there. So at 1. Okay, those are my critical points. So I'm going to put those all onto a number line at this point so I can start to see what's going on around those values, because we know the way critical points work that things happen around. We have to look at what's going on around each critical point. So I'm going to look at negative 1 is a critical point, and then I've got 1, and then I have 3. Okay. So at this point, I need to do a first derivative test. So when I do the first derivative test over here, I'm going to take the first derivative. I'm going to see what's going on. So I'm going to test at what's going on at x equals 2. I'm going to test at what's going on at x equals 0. I'm going to test at what happens at x equals 2. And then I'm going to test at what's happened at x equals 4. Okay, I'm going to use a graphing calculator to get those values. So when I use a graphing calculator, okay, I'm going to just move this calculator over to the right of the screen here. I got to put it right there so you can still see it. All right, so into y equals, I have, this is the original function, but I've plugged in the derivative under y1. So I'm going to go vars, and I'm going to evaluate y1 at 2. Okay, and that's going to come out undefined at 2. Oop, I should have done -2 over here. So let's double check. This should have been -2. Okay, so I just found out at 2 it is positive. We'll go with that. Okay, and let's take the same function and evaluate it at -2. Okay, now that is undefined. So we're just going to write over here that it's undefined here. Okay, so we'll look at what's going on there. It's also going to be undefined at 4. So let's see what's going on at 4. And again at 4, undefined. So over here at 4, it is undefined. Okay, so we know it's positive here. Now we just want to know what's going on at 0. So quit, and we want to know second quit at what's going on at 0. And I've got a positive value. Interesting. No, that I had a negative value, right? All right, so let's fix this. At 2, it was a negative answer. So we got to fix that. At 2, it was negative, and at 0, it was positive. Okay, so we go back and confirm this. At 2, it was negative, and at 0, it was positive. Okay, so now if we draw a little sketch here, I'm going to have a max, and then I'm going to have a min. So that's going to give me a max right here. Okay, so now we got to figure out what's going on. Why is it undefined over here? So we found a max, and now we want to know what's going on after we're there. So if we go back up to our function, we know that the function has to be greater than 0. So basically this function, the domain is restricted. The domain only goes from -1 to 3. So it's undefined here because the domain starts at -1 because you have to be greater than or equal to 0, and it goes to 3. So this section, our graph only goes from here to here. Okay, so now that we know a little bit more about our graph, we can say that we're going to have a max, and we're going to have a max value, okay, of 1, and then what I need to do is plug 1 into the original equation. So under y2, I have my original equation, so I'm going to go second quit, I'm going to go vars, y vars, and I want the second equation. I'm going to plug in at 2. I get 1.73. Okay, so that's not right. What happened? Y2, I wanted to know at 1, that's why. Okay, I wanted to know what's going on at 1. At 1, I'm at 2. Okay, so I have a max value of 1, 2. All right, now pretty good chance, because this graph is coming down, that these are going to be min values because the graph comes down and it's dropping. So let's look at those values and see what's going on. We know we could have endpoints, so we got to test these. We got to see what's going on at -1, and we got to see what's going on at 3. Okay, so if I go to the graph and I'm going to plug in second quit, I want to see what's going, second enter, sorry, what's going on at -1, enter, it's 0. Okay, so at -1, 0. Okay, and then I want to see what's going on at second enter. I want to see what's going on at 3. And I get 0. Okay, so those are min values. Okay, so I have a min value here. And these are both minimum values. So I have a min value. These are both min at -1, 0 and at 3, 0. Now, let's go look at the graph and see if we agree with that, what we just came up with here. So I'm going to graph the original function right here. Okay, so what we came up with our original function was that we had a min at -1, -1, 0, good, and we had a min at 3, 0. And it also said we had a max value at 1. And if we look, as soon as we go to the right or the left of 1, the y values increase. So that is your max value.